Okay, so today we're going to discuss expected value of a probability distribution. Okay, so we already know how to construct one, and then we'll now deal with the calculations. Okay, so let's define what expected value is. So let x be a random variable with a given probability distribution f of x. Okay, so the mathematical expectation of x, also called the expected value, also called the mean of x. So you're talking about the average. Okay, it's denoted as mu, or sometimes it's called e of, sometimes it's called mu, and then e of x is given by the formula here. So e of x equals the summation of x times p of x. Okay, which means I have to multiply the value of the variable with its probability, and then after adding all of them and you get the sum, that's going to give you the expected value. Okay, let's have an example. Okay, so this is the example from the past PowerPoint. Okay, so the probability distribution for the personality inventory test for the passive aggressive trait is, given. So find the mean. So notice these are the probability distributions that we did, right? So to find the mean, basically all you got to do is simply multiply. Okay, multiply this one. Oops. Multiply 1 by 16, 2 by 22, 3 by 0.28, 4 by 0.20, and 5 by 0.14. And then when you get the sum, you have now your expected value, which is equal to 2.94, or approximately 2.9. Okay, so next example. Okay, so this one, pay attention. Okay, so suppose we roll a fair six-sided die 100 times. Okay, and then we keep track of the results. Okay, and at the end, we add up the results of each roll. So what would the average sum be? So basically what we're going to do here is, if you want to illustrate what happens, is you roll the dice 100 times. And every time you roll the dice, you take note of the number. And then after rolling that 100 times, you add them all up. Okay? So what would the average sum be? Okay? Okay, so the easiest way to do this is to determine the average number that comes up on one single roll, which is actually, since the die is fair, it's going to be 1, 2, 3, 4, 5, and 6, which means the probability of each is 1 over 6. So we have now this probability distribution table. Okay? Okay, so that's the probability distribution for one roll. So basically, all you got to do is basically multiply this, multiply, 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 and after that you add them. So what you're going to get would be e of x equals 1 over 6. 2 times 1 over 6 is 2 over 6. 3 times 1 over 6 is 3 over 6, and so on. And you get all of them. And then since they're all the same denominators, all you got to do is add up all the numerators. And that gives me 21 over 6, or simply 3.5. 3.5 is the average on one roll. So since the dice is rolled 100 times, I have to multiply 3.5 by 100, which gives me 350. And that would be the average sum. Okay, any questions so far? Okay, next. So consider a game in which you will roll a pair of dice. If you roll a double, you win $5. If you roll an odd number, you win $2. Otherwise, you lose $5. Okay, so what are your expected winnings? Okay, so up to how much are you willing to pay to play each game? Okay, so since you're talking about a pair of dice, okay, you have 1, 2, 3, 4, 5, 6, and 1, 2, 3, 4, 5, 6. Now your random variable x here are your what? Expected winnings. So the possible values that you can win is actually equal to $5, $2, or you lose $5, which is a negative. So basically, those are your x's. So the problem is, what would be the probability, right? Just like this. So your x would be 5, 2, and negative 5. So what would be the probability? So the easiest way is to find the dice configuration, right? Okay. So if I'm going to do the dice configuration, let me move this one. Okay. Okay. this would be 1, 2, 3, 4, 5, 6, and 1, 2, 3, 4, 5, 6 on top. So these are the possible sums. Oops, where are we? Okay, where's the PowerPoint? Okay, so these are the possible sums, right? That is 1 plus 1 is 2, 2 plus 1 is 3, and so on. Now you're talking about the problem to be if, let's go back here, roll a double, you win a 5, right? So if you roll a double, that's basically this 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, and 6, 6. So that's going to be 2, 4, 6, 8, 10, and 12. Okay, if you get these numbers, okay, 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, and 6, 6. Okay, the ones in the mid, the ones on the diagonal. Okay, you win $5. So which means out of 36, that's going to be 1, 2, 3, 4, 5, 6. So 6 out of 36 if you win $5. Okay. Now, okay, let's go on to 2. Why is it 18 over 36? That is if the number is what? Odd. Okay, let's count how many odds are there in here. So 3, 1, 1, 2, 3. Okay, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, and 18. That's why it's 18 out of 36. Okay, so, and the last one, okay, since this is out of 36, you don't even have to determine the other by just find it over here. All you got to do is just simply complete the table in such a way that it's going to be 36 out of 36. So since this is 6 and this is 18, that's going to be 24. Then the other one would be automatically be 12. So once you got now the probability distribution, all you got to do is just simply multiply them. So if I multiply them and multiply them and multiply them, and if I add them after that, I get now this. So 30 out of 36, 36 out of 36, and 60 out of 36. So this 0.17 is basically the amount that you are winning. So if you continue to play the game over and over and over and over again, your average winning would be about 17 cents. So this is the maximum, I mean, the amount that you have to pay to break even. So this answers those two questions. Okay. So any questions so far? Okay. Next example. So in a gambling game, a man is paid $5 if he gets all heads or all tails when 3 coins are tossed, and will pay out $3 if either 1 or 2 heads shows. What is his expected gain? So there are only two things that happens here. He wins $5, or he loses what? $3, because that's gonna be the gain, right? The winnings. So basically, since you're tossing 3 coins, so 3 coins has what? Again, 2 times 2 times 2. One coin has 2 possibilities. The other second coin has 2 possibilities, and the third coin has 2 possibilities with a total of what? 8. So the denominator should be 8. Okay? So for you to get 5, okay, it has to be what? All heads or all tails. So it only happens when it's tail, 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 or heads, heads, heads. Okay? Right? So that's going to be 2 out of 8. And then which means you lose $3 since it has to be 8 over 8, which means the other has to be 6 over 8. So which means when you simplify that, that gives you 10 over 8 minus 18 over 8 equals -1. So basically, you're not actually winning. You are actually what? Losing money if you completely continue to play this game over and over again. On the average, you're going to be losing $1. So not a good game. Okay? So next example. This one is interesting because this is about lottery tickets. Okay, so consider a lottery with a single jackpot price of $500,000. So if a ticket costs $3 and the probability of it being a winning ticket is approximately 1 out of 1 million, then what's the expected winnings? Okay, so what I'm going to do here again, it's either you win or you what? Lose. So there are two things. Now, if you win, you're actually not winning 500,000. Why? Because before you win 500,000, you have to buy a ticket, right? And the ticket costs what? $3. So you're actually winning 499,997, right? And the probability of that would give you what? 1 out of what? A million. And then if you lose, you only lose what? $3. And the probability of that, since it has to be complete one, would now be 999,999 out of what? A million. Compute E of x. Simplify that, you get E of x equals negative 2.5. So average already, you're already losing. That's why as much as possible, consider playing lotto differently. Okay, so I only play it when the jackpot price is already big. Okay, there's another one. Imagine there's a raffle contest being held at your local community center. Suppose there's a grand prize of 5,000 and two second prizes of 500. If a raffle ticket costs $2 and 800 tickets are sold, what's the expected winnings on one ticket? Okay, so 800 tickets. So the probability of it being the winning ticket is 1 out of 800, right? And the winning is what? Not 5,000, but since the ticket costs $2, so the amount that you're going to be winning is 4,998, right? There you go. And the probability of it is 1 out of what? 800. Now, the second prize is of 500 is not actually 500 that you're going to win, which is actually 400 and what? 98. And there are two second prizes, so the probability is 2 out of what? 800. And then if you lose, okay, you lose only what? $2. And the probability of that is 777 out of 800. So if I compute again E of x, I get now $5.50. Though in here you're gonna win, but this is just a raffle that can only be done one time. Okay, the value of 5.5 here implies that if you are actually doing the raffle contest over and over again. But that's the reason why when I have something in school, a raffle in school, I always ask them how many tickets are being sold. So that gives me the probability of me winning. Okay? This one, another game. Consider the following game in which two players spin a fair wheel in turn. The player who spins the higher number wins, and the loser has to pay the winner the difference of the two numbers in dollars. Who would win more often? And what's the player expected winnings? Okay? Let's look at the spinner. So these are the numbers for player A, and this would be the player's numbers for player B. So if we determine each of them spins, and then whoever gets the higher number wins, right? So let's get the possibilities. So since player A has 3 choices and player B has 2 choices, so the possibility would be 3 times 2 would be 6. So there would be 6 grids. So if I'm going to do that, it's going to be something like this. So player B has 5 and 6. Player A is 2, 4, and 12. So this number means that here player B wins, or player B wins, okay? And A has to pay B $3 because the difference between 5 and 2, right? But this one, the negative is based on A. So A loses here, A loses here too. So he pays, or the player pays $1 to player B. So if based on the 6, okay, 4 of the 6, player B wins. Only 2 out of 6 wherein player A wins. So basically player B wins more often. Okay, but how much? So since these are the case, these are the values for -3, -4. These are the winnings. Okay, so the winnings for basically player A. This is player A's winnings. Okay, because he loses, he loses, he loses, he loses. So this is player A's expected gain. So if I do this, I'll get E of x equals 3 over 6 or 0.5. So even though player A loses 4 out of 6, okay, 4 out of the 6 times, okay, he still wins 50 cents on the average. Okay, so this ends our lesson on expected value. Okay, thanks, guys.